FTC Alberta. Welcome to the long delayed finale to the CAD Challenges from the spring. I lost track of these and lost somewhat motivation for them, so I apologize for that, but at the same time, I think we should get back to them and put some finality on this before we start the next chapter in the 2021 season of Ultimate Goal. That being said, I want to rip through a few of these, and actually I just wanted to show you this cool thing because Amant's actually sent me this one from Team 4042. This is a render of their final drivetrain that they've continued refining after the CAD Challenges, which is super cool. We're going to talk about it in a second. The point of this video, we're going to talk through a few of the designs. There are 4 teams that managed to make it all the way to the end and post their presentations of their final robots. We'll talk about those ones. Those teams have received their letters at this point. If there's any other teams that were part of the CAD Challenge, maybe you've got this thing finished in the back folder somewhere and want to send it off and put it on the Discord, you put it on the Discord, we'll fire you off one of those letters and life will be good. Now, 4042 took on a very cool challenge here because they did the Octodrive, and we've talked about this before, but I love that they actually put this in presentation form on their document and on their presentation here. So the idea that you could have this shifting rocker drive, so you could go between basically a raised center, and as they say, fast maneuverable. I would argue that this is actually potentially could be slower because you lose some power on Mecanum wheels, but the drop center is so cool because it provides that traction, allows you to sometimes get over terrain, make your way ripping around the field, especially when you're driving forward and backward and want that good grippy surface onto the main field. I love that they've actually broken off their different subcomponents here, and we're going to talk about this in the context of this season because something weird has made this very essential in many cases for teams. Okay, spinny tube thing. Okay, hate the name, love the concept. Everybody built a similar intake to this, and you're going to see this a lot in FTC robots, where you have some sort of spinning, often flexible device that's going to take hold of whatever objects they are. The reason we spin with these is because it's easy to transfer rotary motion from a spinning motor to something that spins. It's much easier than something going linear, for example. As well, we often use something flexible because you don't want things getting stuck. Worst thing that can happen to a robot in many cases is getting the game piece stuck in your robot so you can't use it because then really you got nothing to go on. And I just wanted to point out that multiple teams did this one, but the turret is a cool idea, and I'm going to leave 4042 with a little bit of advice, and this is from me, because you guys took a giant chunk out of this. You took a giant bite, took some very complex things, and I'm going to suggest, and this is me as a mentor, if you actually carry this through to the Ultimate Goal season, there's a couple things I want you to do. First of all, keep naming your things in this awesome way. They called it Manual Desk instead of Autodesk because they used Onshape. It's hilarious. You should always include a terrible pun in your name if at all possible, or perhaps some theming in your name. Don't be like my team a few years ago when we named the robot Untitled.Robot because they forgot to name the robot. True story, it happened. You can ask that team from 7277. That being said, this is a super cool differential turret. The idea that you could move this using a limited number of motors. But the one thing I would advise, if you're going to take this to a season, 4042, is I would actually simplify things as much as you can. You actually have 2 redundant systems here. The Mecanum wheels are here to help you maneuver. They're help you to get into exactly the right spot to take the shot. Likewise, you now have a turret that also rotates. You've added multiple degrees of freedom. Now, in some cases, this can work really well. If you look at the high levels of FTC and FRC that have automatic targeting systems and things like this, it can work. However, often you're going to find that a turret does the same thing as Mecanum wheels, and so having one or the other saves you a lot of points of failure. And that's a point that one piece of advice I would give 4042 is limiting your points of failure during an actual build season is going to serve you very well because you've got some very cool things designed here, and the less points where those things can go wrong during a match, the easier it is. And simplicity sometimes goes a long way in these sort of things. Let's roll on here. We're going to talk about 14717 and 15259 and the Plunger Bot. By far the worst named of all of these, but hey, they got the team colors right on the presentation, so good job, guys. Well done. That being said, the Plunger Bot was actually born out of a suggestion from one of our mentors who actually went to the World Championship with 7277 with our parent FRC team in 2019, and we got to watch the absolute disaster. There's a bit of a story here that was the Team 254 robot, and I won't say disaster because we're talking about a robot here that, along with Black Hawk Robotics 3310, actually made it to the world final. They made it really super far. It was amazing. But this 254, arguably one of, if not the best team in the world. They've won world championships for years and years. In 2018, we got to watch them go undefeated. Last year, 2019, they created this robot, and they actually made it to the finals. I recommend you look up Einstein Finals in Houston in 2019 to see what happens when a match really badly goes wrong. But beyond that, what they created here, and this is the same challenge you guys had for climbing high, was the idea of the 3 steps. It was modeled after First Deep Space. And 254, this robot here, is actually hanging on by suction power. It's actually using a compressor, wired in reverse, that actually is sucking the air out of a plate. And you can't see it here, it's behind 3310. But they just had a big flat plate with a flexible bottom that they would stick down, suck the air out of, and create a vacuum. And they could actually cantilever themselves up in the air. Thus, PlungerBot was born. Now, the cool thing with 254 is you could fit more robots onto this actual space because you use this method. You could actually, you'll see 3310 is here, 254 is here. 3310 actually ended up having their own version of this mechanism as well, that they could actually at one point get all 3 robots up on the side of the step here. And so PlungerBot was born out of this. And it was based off of the idea that you could bring multiple robots up onto the platform. This yellow thing you see here, and I'm going to see if there's a good picture of it in here. Here we go. Here's a good picture. This is actually a windshield holder from Home Depot. It's technically what they're usually used for. It's a glass holder. You may have seen it as a suction cup, and basically you put the thing onto something, you pull a lever, and it sucks the air out, and you can use it as a handle to pick up something flat and rigid. Now, good news is, the platform is flat and rigid, and if you rotate something 90 degrees, sometimes you get something completely different. Now, this was the idea that you could take this arm, and don't worry, I'm going to critique one of the teams that I founded as well, because that's kind of how we roll here. This is actually going to suction itself onto the platform. The idea being that this arm would then lift the rest of the robot up. Now, the other cool thing, and again, this is harkening back to FRC 2018, where a lot of robots did what was called the buddy climb. They actually put a ramp on this thing. Love it. It's one of the pictures here. They actually put a ramp on the side where you could deploy this and lift a second robot up with you, because that's worth even more points. And that unto itself is actually a very, very cool concept. Now, the one thing that I will advise for this team, if you ever attempted this piece on an actual build, is you have some massive forces going on in lever arms here. And I'm going to point out 2 of them. These are the big ones that I would always point out to a team looking at something this size. What you have here are the longest possible Tetrix extensions you have making up that arm. Those Tetrix extensions are heavy. Yes, they're durable. Yes, they're rigid, but they're also very heavy. They're carrying a relatively heavy thing on the end of them, and if you gear them properly, they will work. If you build them improperly, though, they will also sometimes fail, and that's where this becomes a little bit, problematic. The other piece here that I would advise for this group is to simplify this. Right now, you've got an arm that actually has 3 separate degrees of freedom at it. It has basically a shoulder, an elbow, and a wrist, if we had to use the human anatomy analogy, and that doesn't work very well. You want to minimize the number of points that you could actually go with. If you look at the Cheesy Poops robot here, it actually had an arm that had 1 point of articulation, 1 point of motion. It would just drop down, it would suction on, and then this whole thing was on a linear slide. So we actually only had 2 degrees of freedom on this one, which is kind of cool. I also want to warn the teams that if this happens to be a challenge in Ultimate Goal, if you read the game rules, the manual part 1 for this year, because we always release a part 1 game manual with some of the kind of basic overarching rules, it seems as though suction is not going to be allowed in this year's game. So this one actually may not be legal. We'll have to check it if there is a component of this in the actual game. That being said, good job with the use of fusion here. Good job with custom lasered parts, and this is one that I would implore teams to explore. If you have somebody who's able to do some of the lasering for your team, you can create some really cool things with a custom lasered part, or in this case, the team has also found a way to actually bolt in a commercial off-the-shelf, a COTS part, and put it and integrate it with their robot in the form of this piece here. Also, for anyone looking at this, there is a tornado on the very end of a lever arm. Please try to avoid doing that. Servos are better because they're lighter on the end of the lever arm, and there's some major moment forces going on in there. If that sentence or any piece of that required you to Google 2 or 3 things, good job, you learned something today. Fantastic. Let's cut our way over here to Confusion 360, another one of my very favorite named things from Team Fix-It and the Cyber Eagles. You guys have done a fantastic job on this one, so let's just rip through here, okay? The base that they used is what is called a West Coast drive. Now, so far in this, we've seen the Octo drive, which is the version from 4042. We've seen an X drive, which were very common in the most recent season when we were playing Skystone. But West Coast drive is something that's hugely popular in FRC. Now, what is a West Coast drive? You'll notice that this drive right here actually has a drop center wheel. This wheel is lower than the front and back wheel, and that kind of makes sense because if you have 6 wheels on the floor and you try to turn, you try to pivot around a point, you're at any given point, if all your wheels are at the same height, you're going to have 4 wheels preventing you from rotating. That's not good. That's why a lot of teams that do 6-wheel drives will put Omni wheels on the front and back of their robot to make it easier to spin. But the other thing you can do, excuse me, which is very cool, is you could actually drop center of your robot. If you balance this robot together, when it tries to spin, it's actually going to balance on those center 2 wheels. The other 4 wheels are going to be flipped up in the air as you spin, and you receive less resistance as you spin. This is super cool, and a lot of FRC teams use this design almost exclusively because it's really effective when dealing with the field. The downside is it's not very good for maneuvering. It doesn't deal very well with moving left and right or strafing, which is something that some of the other Mechanims and X drives do much, much better. And I also want to say, good job. You guys have built something that's very effectively going to bring in the actual game balls here and potentially shoot them as well. I actually wasn't quite sure what you were doing with your climber, so I'm not going to comment on this one. But I love that you did the hooded shooter, because really there's only a couple of styles of shooting something that we really should be worried about. In this case, you've got the West Coast drive. You can't strafe, so a turret is the perfect choice for this sort of thing. It's a really good way of actually rotating a targeting mechanism on top of your robot so that you don't have to strafe. You could actually drive forward and backwards while turned sideways to a platform while shooting at it sideways and aiming. It's often one of the few times in FTC having 2 drivers is a really good thing. One to operate the drivetrain, one to operate the shooting mechanism. Works really well as long as you communicate fairly effectively. All told, guys, fantastic job on this one. I really like that. Lastly, I just want to pop over to the Genesis bot from the Data Wolves from Team 1300. You guys did a great job with this with Fusion 360. And I just want to show this one off because it actually has 2 things that other teams didn't do, and very specific things. You've got the Mechanim drive, fantastic, good for strafing, and you did a fixed shooter. There's no turret, there's no movement, and there's nothing wrong with that, because if you can get into the perfect spot on the field, you can take the shot, and that's awesome. That being said, what Team 13,000 has done is they've actually done a double flywheel shooter. So you've actually got multiple wheels here. If we take a look here, we've got wheels on each side of the ball, and those are meant to, in essence, squeeze the ball out and take the shot. They're not really good for taking really, really long shots. Excuse me. Because if you take those really, really long shots, the ball doesn't have spin on it, and it likes to move all over the place. We ran into that in FRC this year. But what it does do really well in this game, because all the shots are relatively short range, farthest shot is realistically just over 18 inches long, it will put that ball in the target pretty effectively. Love that. And then I see there's some space where you can modify the angle a little bit to get the exact spot where you want to take the shot from. I also want to say I like that all the robots had the same general idea where you would bring something in from ground level. Your intake was nice and low. And I suspect that this year's game with Ultimate Goal, and I am assuming that with a name like Ultimate Goal, that we are shooting some kind of object. We are going to be throwing or shooting or tossing something. Having that ground-mounted intake can actually be a really good thing. And this is a fantastic example as well. I want to throw this out here because your targeting arm was one of the most unique things. A lot of robots I saw were looking at the idea that you could play autonomous with what you already had. And 13,000 didn't do that. They actually built a separate subsystem for autonomous, and that's really big because if you read the game rules for this year, if you're participating in remote events, the first tiebreaker on points is going to be your autonomous points. So having autonomous is going to be hugely important. And this is a great idea. This is a great idea with having a sensor sitting in front of your robot, sensor right here, and actually having this so you could roll it, basically use that sensor to drop something down onto the ball and control it. This is super simple. This follows all those principles because there's not a lot that can go wrong on this one. There's one sensor, there's one servo, there's not a lot of moving parts, and that kind of thing goes a long way in robotics competition. Because if you have the choice between solving something with a simple mechanism and a complex mechanism, you should always, always, always choose the simple mechanism. That's exactly what Team 13,000 has done. Also, very beautiful robot to look at. One piece of advice I would have if you ever try to do this particular mechanism, the actual hex core motors that you've chosen to use here may not be fast enough to make this shot. You may have to include some sort of gearing on this to actually make those spin a little bit faster to actually make the shot on this one. And I say that mostly due to my experience with the first global program where we actually had to do a similar challenge. Okay, let me rephrase. We chose to do a similar challenge with the same style of motors in the last event when it was in Dubai in October of 2019, I want to say. Anyways, the team from Alberta went and actually played with a flywheel, and we had to gear those motors up like mad to make the shot. And it turns out the team that won didn't actually do that strategy at all. They did something completely different, which was, we didn't read into it at all. That being said, good job 13,000. Very well done. I'm going to hop back here quickly to back to 13,000. I'm seeing a subsystem that was designed to be bolted onto a robot chassis. It was designed to be just added and put together as different pieces of different systems. This is something you can do as a team, where different team members design different pieces of the robot, and then maybe one or two team members who are able to safely work on the robot, maybe they're siblings, they are in the same space, can actually do the assembly at the end of the day. Maybe they send the robot off to somebody else to actually do the driving. At the end of the day, it's going to be one of those pieces where that kind of collaboration, where everyone works digitally, everyone works online, everyone brings their ideas together into one, I'm going to say, generally cohesive design. And you guys have put together some really cohesive designs here that could become real-life robots. That kind of thing will go a long way this year into making teams work in the most safe way possible. Because in some cases, we're going to have teams that are at schools where we may not be able to meet with any regularity. We may be sanitizing all the tools we're using. We may have all of these other restrictions in place. Or your team may not be able to meet at all. It may be a case where some of you design things digitally, and then one person builds them, and then someone else drives it. That may be your team. Who knows? This season is going to be weird. That's all I know. You're going to have to be flexible. You're going to have to show all of these things that FIRST tells you, which is that when you go into that competition, you're not sure what you're going to be facing. Things are going to break. Things are not going to be ideal. And the one thing that you're all going to do is that you, as the future scientists and engineers of our world, are going to innovate. You're going to persevere through it. Use that flexibility to design something absolutely amazing. With that being said,